Good morning, my dear students. So today in these sessions we are going to learn the next problem in which we need to find out the nodal displacement vectors as well as we need to find out the stress on each element, okay, as well as we need to find out the normal reactions on the first node, second node and third node. We need to find out, okay. So first of all I will read the questions. Okay, a column, it's made of mild steel, so in which we need to find out the nodal displacement as well as we need to find out in the second condition is nodal force, means the nodal displacement is Q1, Q2, Q3 we need to find out, as well as we need to find out the reaction force at the support. So this means that we need to find out the reaction R1, R2, R3 we need to find out, as well as we need to find out in the third condition is stress and strain for the first element and second element. That's it. This is the first element and this is the second element. So let us see, this is one block, okay. So this block we can say as a second element block. Upon them one more block is there, so it is capturing on the second block. The first block is placing on the second block. So on this first block, this compressive force is acting as the 1000 Newton force is the compressive force is acting on the first block. The length of the first block is 100 mm. It is represent the L1, and this is the second length of this block is L2, okay dear. So it is given here, and the thickness of this block is given as 10 mm, and the modulus of elasticity of the mild steel, because this first block as well as second block it is made of mild steel. For that reason the modulus of elasticity or Young's modulus value it is remaining same for the first element as well as for the second element. For the first element E1 is equal to 2 into 10 power of 5, okay, Newton per mm square for the mild steel. And it's the same thing for the second element. The modulus of elasticity or Young's modulus E2 is equal to 2 into 10 power of 5 Newton per mm square for the mild steel. Okay, so if you observe here, so this is we can say as the first node, and this one we can say as the second node, and this one we can say as third node. It is represented here one first node, second node and the third node. The length from the first node to the second node is L1, and the node from the second node to the third node it is represent the length L2, and the nodal force is acting at this point F1, and the nodal force is acting at a point of second which is represent as F2. The nodal force is acting at a point of bottom, it's we can say as the force F3. Along with the force, the nodal displacement is acting Q1 is the nodal force F1 is acting at a point of 1, and the nodal displacement is acting at a point of 1. And meanwhile the same thing, the nodal force F2 is acting at a point of 2, and the nodal displacement is acting at a point of 2. It is represent the Q2. And the nodal force if it is acting at a point of 3 it is represent as force F3, and the nodal displacement if it is acting at a point of 3 it is represent the Q3. Clear? I hope so. No one is having a doubt up to here. This is the first node, second node, third node. First node, second node, third node. The element from the first node to the second node, this is what we can say, this is the first element. Joining from the second node to the third node, what we can say element second. Okay, after that what we need to find out, we need to find out the elemental stiffness matrix. We need to find out in this case, if you want to find out the elemental stiffness matrix, KE is equal to AE by LE 1 minus 1 minus 1 1. For the first element, that is instead of KE we have to represent as K1 equal to, instead of AE we have to present as A1, instead of EE we have to present as E1 by L1 1 minus 1 minus 1 1. Okay, After that, so the area of the first cross sections, how much is given? The area is given as 100 mm square. 100 into the modulus of elasticity of the material is given as 2 into 10 power of 5. The length of the first element is given as 100 mm, and 1 minus 1 minus 1 1 remaining same. After that, if you divide the whole the component, then you will get the values. If 100 and 100 will cancel, the remaining term should be 2 into 10 power of 5. 1 minus 1 minus 1 1. After that, this 2 we need to multiply in the bracket. 2 ones are 2, and again should be minus 2 and 2. So this first node and second node, if you join, they forming of which element here? First element. So for that reason, we have to represent this first node, second node, first node, second node. Okay. And the second thing, we need to find out for the element 2. For element 2, stiffness matrix, if you want to find out K2 equal to A2 by L2, 1 minus 1 minus 1 1. So area of cross section of the second element, it is given as 200. The modulus of elasticity or Young's modulus of the material is given as 2 into 10 power of 5. But length of the second element is given as 100 mm. 1 minus 1 minus 1 1. If you divide the whole the component, then you will get the answer is 4 into 10 power of 5. 1 minus 1 minus 1 and 1. And 10 power of 5 as it is, just you need to multiply the term. 4 ones are 4 minus 4 minus 4 and 4. So this second node and third node, it is like the element, what we can say, elements second. Let us see the joining second node to the third node, second node to the third node, the forming of which element? Element second. For that reason, I am representing here for the element 2. If you want to find out element 2, you need to join the node second and third node you need to consider. This is the second node, third node in which this element 2 it lies. Okay. After that, after the getting the elemental stiffness matrix K1 and K2, you need to add. If you adding K is equal to K1 plus K2, what we can say? This K we can say as global stiffness matrix. Global stiffness matrix always equal to the first elemental stiffness matrix plus second elemental stiffness matrix. Okay dear. K1 value we know very well, how much? 10 power of 5, 2 minus 2 minus 2, 2. Okay, 2 minus 2 minus 2, 2. This is the first node, second node, first node, second node plus 10 power of 5, 4 minus 4 minus 4, 4. Second, third, second, third. After that, we have to arrange the node in the systematic manner. So I am representing here first node, second node, third node in the horizontal direction. First node, second node, third node in the vertical direction. How to multiply first node to first node to the second node, that is important. Just same concept we need to follow here. Just you need to multiply first node to first node, how much you will get? 2. First node to first node, how much you will get? 2. First node to second node, how much you will get? Minus 2. I am representing here minus 2. First node to third node is available here? Not available. If it is not available, it is considered as 0. Clear? Again, second node to the first node. Second node to the first node. How much you are getting the value? Minus 2. Second node to the second node. How much you are getting the value? 2. Again here also. Second node to the second node. How much you are getting the value? 4. Clear? Second node to the third node is available here toward this side? Not available. Just you need to eliminate. Go for here. Second node to the third node, how much you will get? Minus 4. Third node to the first node is available here. Here also not available. Here also not available. If it is not available, it considered as 0. Third node to the second node is minus 4. Third node to the third node is 4. Again, 10 power of 5 as it is. 2 minus 2 0 minus 2. 2 plus 4 should be 6, minus 4, 0, minus 4, 4. 1, 2, 3, first node, second node, third node, first node, second node, third node. So this K is represent the global stiffness matrix we are find out. Again, what we need to find out? Our main intention is we need to find out the displacement vector as well as the global force vector we need to find out in this problem. Okay, then let us see. the Q equal to, how many nodes we have here? We have 3 nodes, Q1, Q2, Q3. The nodal displacement is acting at a point of 1 and it is represented by Q1. The nodal displacement is acting at a point of 2, it is represented by Q2. The nodal displacement is acting at a point of 3, it is represented by Q3 equal to, F equal to, the nodal force F1 is acting at a point of 1 is how much is there? 1000 Newton. The nodal force F2 is the fixed end, so that's why it is considered as 0, because nodal force F3 in which there is no force is acting at the point, at the node 2 there is no force is acting, it is considered as 0. At the point 3rd there is no force is acting, again it is considered as 0. Clear here? If you have the dot means, let us see this figure. Then this is 1, this is a F1. The nodal force F1 is how much force is acting? 1000 Newton is acting. At this point any force is acting here? No force is acting. If it is not acting, it will be considered as 0. Here any force is acting here? No force is acting at this 3rd point. So again the value should be 0. F1 is 1000, F2 is 0, F3 also 0. Clear here? I hope so no one is having a doubt up to here. After that, what we need to find out? We need to find out the equilibrium equation for a given continuum. We need to find out. If you want to find out the equilibrium equation for a given continuum, we have the formula is KQ equal to F. K, what they represent? The K is represent the global stiffness matrix. What they represent? Global stiffness matrix. Q represent the nodal displacement, and F is represent the nodal force factor. Clear? And the K already we find how much here? 10 power 5, 2 minus 2, 0, minus 2, 6, minus 4, 0, minus 4, 4. And the nodal displacement Q1, Q2, Q3, 0 equal to here F1, F2, F3. F1 value is 1000, F2 is 0, F3 also 0. So we know very well here node 3, how's it? Is totally fixed to the womb, to the bottom, to the womb, bottom. If it is fixed, then we need to eliminate this 3rd row, 3rd column, 3rd row, 3rd column. Okay dear? After that, we need to apply the boundary condition with the help of elimination approach method we need to follow in this case. 10 power 5 as it is, 2 minus 2 remaining term should be 2 minus 2 minus 2 6, and Q1 Q2 equal to 1000 0. Again what we have to do? Let us see 10 power 5 as it is. Just you need to multiply the term 2 into Q1 2 Q1 minus 2 into Q2 minus 2 Q2 equal to 1000 Newton. Again the same concept we need to follow for the second element. First I am going for the first element only. Let us see 2Q1 minus 2Q2. If you divide this value, then you will get the value of 0.01. So it is considered as equation number 1. Again we have to follow the same concept, 10 power 5 as it is. This second row, first column we need to multiply. Second row, first column, minus 2 into Q1 plus 6 into Q2 equal to 0. Again, if you divide 0 by anything, it should be become as 0. 0 by number should be 0. Minus 2Q1 plus 6Q2 equal to 0. So it is considered as equation number 2. If you are equating the equation number 1 and equation number 2, then you will get some value. Let us consider here. Let us see on the screen. So what is the equation number 1? 2Q1 minus 2Q2 equal to 0.01. Equation 2 is minus 2Q1 plus 6Q2 equal to 0. Then, so here minus will be there, here plus will be there, these terms will be cancelled. The remaining should be 6 minus of 2 should be how much? 4, Q2 equal to 0.01. If you divide this one, 0.01 by 4 equal to how much you will get? 2.5 into 10 power of minus 3 mm. After getting the value of Q2, then you need to substitute in the equation number 1, then you will get the value of Q1. Is it right? Equation number 2 is minus 2Q1 plus 6Q2 equal to 0. Minus 2Q1 equal to, if this positive sign, if it is moved toward the right side, it will become as minus. This minus and minus will cancel. The remaining term should be 2q1 is equal to 6. q2 value is 2.5 into 10 power of minus 3. q1 equal to, if you divide this value, then you will get the answer of 7.5 into 10 power of minus 3 mm. Okay, so in this case we find out the value of q1, q2, q3 is the fixed and it is become as 0. After the getting the nodal displacement value, we need to find out the stress and strain value. How to find out the stress and strain? That is the most important. Strain, if you want to find out, E1 is equal to B1 into Q. Strain 1 by L1 minus 1 q1 q2, 1 by length. L1 is how much is there? 100 minus 1 and q1 value is how much we got here? q1 is 7.5 into 10 power of minus 3 and q2 value is 2.5 into 10 power of minus 3. Then again you need to follow the same concept, same I did here directly. 1 by 100 minus 1 into 7.05 into 10 power of minus 3 plus 1 into 2.5 into 10 power of minus 3. If you divide the value by 100, then you will get the answer of minus 5 into 10 power of 5. Because strain is not having any unit, it is a dimensionless unit. It is a dimensionless unit. Okay. Again, after getting the strain, we need to find out the stress. How to find out the stress? We have the same concept, same formula we need to follow here. Stress is equal to Young's modulus into strain. Capital E as it is. Wherever the B1Q will be there, you have to substitute the value of E1. E1 how much will be there here? Modulus of elasticity or Young's modulus value already is given how much? 2 into 10 power 5 for the mild steel into E1 how much? Minus 5 into 10 power of minus 5. If you multiply this term, then you will get the value of minus 10 Newton per mm square for the first stress. Okay, so in this case we find the stress for the first element, strain for the first element already we have find. Again the same thing, we need to find out the strain for the second element as well as stress for the second element we need to find out. Okay, so let us see. Next one, second one, strain. Strain E2 is equal to B2 into Q. 1 by L2 minus 1 Q2 Q3. 1 by length, the length of the second element is given as 100 minus 1. So Q2 is how much is there? 2.5 into 10 power minus 3. The Q3, the displacement at 3 should be become 0 because of it is a fixed end. Okay, not here. Then 1 by 100. So just you need to multiply this row into this column, minus 1 into 2.5 into 10 power of minus 3 plus 1 into 0. Then if you divide the whole the value, it will become as minus 2.5 into 10 power of minus 3. Because strain is not having any unit, it is a dimensionless unit. What we can say? Dimensionless unit. Please come on along with me. So strain is not having any unit, it is a dimensionless unit. After that, what we need to find out? Stress we need to find out. The same concept we need to follow here. Sigma 2 is equal to E2 B2 into Q. So here E2 as it is, B2 into Q, what we can say? Strain. So how much we are getting the value? Minus 2.5 into 10 power of minus 3. Then modulus of elasticity for the second element is 2 into 10 power of minus 5. If you multiply this term, then you will get the value is minus 5 Newton per mm square. So after the getting the value of sigma 1, E1, sigma 2, E2, again what we need to find out? We need to find out the normal reaction at the support we need to find out. Then how to find out? The same concept we need to follow here. R is equal to K into Q minus of F. R is how many nodes we have? 3 nodes. For that reason the normal reaction is acting at a point of 1, the normal reaction is acting at a point of 2, the normal reaction is acting at a point of 3, equal to, and K is the global stiffness matrix. Already we found 10 power of 5, 2 minus 2, 0, minus 2, 6, minus 4, 0, minus 4 and 4. Then Q is the nodal displacement. How much will be there? 7.5 into 10 power of minus 3, 2.5 into 10 power of minus 3 and 0. So this one is represent the Q1, Q2, Q3. Because Q3 is the fixed end, it's become as 0 minus F nothing but F1, F2, F3. The force is acting at a point of 1 is 100. The force is not acting at a point of 2, it become as 0. The force is not acting at a point of 3, it also become as 0. Again, we need to follow the R1. We need to find out the value of R1. How to find the same concept we need to follow here. R1 is equal to 10 power of 5 as it is. Just you need to multiply this row into this column. 2 into 7.5 into 10 power of minus 3 minus 2 into 2.5 into 10 power of minus 3 plus 0 into 0 minus of 1000. So after that, if you are multiply this term, then you will get the value is 1000 minus of 1000, it will become as 0. After that, we need to find out the value of R2. The same concept we need to follow here to find out the value of R2. R2 equal to 10 power of 5 as it is. Just we need to multiply this row into this column. Minus 2 into 7.5 into 10 power of minus 3 plus 6 into 2.5 into 10 power of minus 3 minus 4 into 0 minus 0. After that, if you add this whole the value, it will become as again 0 Newton, because this minus 0.05 will be cancelled and this will be cancelled. So 10 power of 5 into 0 should be how much? It should be 0. And R3 if you want to find out, then you have to go for it. This R3 is equal to 0 into this row into this column. 0 into 7.5 into 10 power of minus 3 minus 4 into 2.5 into 10 power of minus 3 plus 4 into 0 minus of 0. We have to represent here. Again it will become as R3 is 1000 Newton. So R1, the normal reaction is acting at a point of 0. The normal reaction is acting at a point of 2 also 0. The normal reaction is acting at a point of 3 is 1000 Newton. Okay dear. After that, what we need to find out? We need to find out the nodal displacement we need to find out. So in the result you have to show that, because already we have find Q1 value, Q2 value, Q3 value, and stresses value is E1, strain value is E1, stress value is sigma 1, because strain E1 is how much we got here? Minus 5 point into 10 power of minus 5, and stress for the first element how much we got here? Minus 10 Newton per mm square, and strain for the second element is minus 2.5 into 10 power minus 5. Stress for the second element is minus 5 Newton per mm square, and the reaction at the support R1 is 0, R2 is 0, R3 is 1000 Newton. So that is the conclusions of your problem. I hope so no one is having a doubt regarding up to here. If you have the doubt regarding this class, please write down in the comment box. Please like, subscribe my channel. Okay dear, thank you.